Let's talk about how to control the lighting in your VPython code. Maybe you've got some wonderful animation you want to demonstrate to your students. Maybe you are wanting to make a little 3D indie movie, or maybe you want to do some physics based on the direction of light that's traveling. You want to teach ray tracing, etc. VPython allows you to do this with some simple light functions that you can control. By default, there are 2 light sources in every scene you create. Here I've got a scene with 4 spheres just to give us something to look at in the scene. What happens is if you access this list called scene.lights, this contains all the lights that are created in your scene so that you can find out where the light is coming from, how bright it is, and what direction it's pointing in. So right now, all I've done is created these 4 spheres. I haven't added any extra lights. And so this printout here is showing you what the default lighting looks like in a VPython canvas. So by default, you're going to have these 2 options. Each one of them lists the light's position, the direction it's shining in, and the color that it provides. So first, let's take a look at the positions. You notice that the positions are undefined because these are what we call distant lights that are coming in from infinity. So we have this concept in optics where light is coming from very, very far away such that all the light rays from it are parallel, right? So you could actually use this to teach a little bit of optics qualitatively at least. So these default lights are coming in from infinity. You will never get on the other side of the light. They're always going to be coming in from farther away. Then we can take a look at their directions. That's the second item that we see here, these 2 vectors. So by default, there's a light source coming in from a little bit to the right and a little bit up, but mostly they're along the positive z-axis. And then you have one coming from an almost, I guess it's not the opposite direction, a permuted direction. There's probably some technical operation that went into there. But it's coming in mostly from the left, and then it's going a little bit down, and then going a little bit in the negative z direction. And so basically these are the 2 lights that you see here. The first one is this kind of main light that we see that's illuminating us here in the front, but then you also might notice that there's this little bit of specular reflection in the back that's coming in from this second lighting source here. How do I know which is which? Well, because in the color, we get to specify what color it is and also how bright it is. And you might notice that the one coming from the front is much brighter. The one coming from the back is noticeably dimmer, right? It's sort of like I have my overhead light coming in from over here, and then maybe I have a table lamp coming in from over in this direction. I can actually see both of them reflecting off of this sphere from this view, so that gives you an idea of what their different directions are. But you notice that for the first one, it's much brighter. It's a 0.8, 0.8, 0.8. Now, when your RGB are all similar, or all the same value, you're going to be getting some flavor of white light. So this is pretty much white light. It's a little bit dimmer than 100% on each RGB, but then the other one is 30%, 30%, 30%. And that gives us this much dimmer view from the back here. So you actually have this nice little shadow coming in right here, this little equator that we've got there. And so by default, those are the 2 lighting sources that are included in your VPython scene. So if you're not worried about the lighting, you can just leave those as is. It works for 99% of the applications I've created. But let's suppose you want to play around with the light a little bit. Let's suppose you want another source coming in from infinity. Well, I could have a source from infinity if I use the distant_light function. Distant_light takes 2 arguments here. The first is going to be what direction you want. This is a vector that says what direction you want it to be. I believe this is the direction you want it coming from. I'll double check that when we actually run the thing. This is the second item that we have here in the printout. And then you can also specify the color, right? These colors were some shade of white. Now let's try a shade of green just so we can make sure we know where it's coming from. I'm going to press Control 2 to run. And you notice a couple things. First, you notice that I've got green light coming in, and it's coming in from the left. Okay, so this is the direction that the thing is coming from. So this is basically out giving you a direction of where the thing is coming from. I suppose I don't technically need a 2 there. I could just give that a -1 and make this a unit vector. Yeah, that doesn't change at all because it's going to change that into a unit vector anyway. But what you notice is I get a third output here when I go to print all of the information from scene.lights. I now get a distant light source with an undefined distance, or with an undefined position, excuse me, because it's all the way out at infinity that way. Then I've got -1, 0, 0. That's my direction that's coming from. Actually, I didn't notice. Did it convert that to a unit vector, or does it store it as -2? Okay, it does store it as -2, so maybe there's some significance to that. I don't notice a difference in the shading there. But then we have the color. Color gets reported as a vector because it is in a red value, a green value, a blue value, RGB. So it's all in the green. It's all in the second item there. And so I can do this with as many light sources as I want. So for example, I might add a light source coming in from the right. Let's color that one blue. Again, you notice I get another output here. It's infinitely far away, and it's coming in from the right, 2, 0, 0. And there I get my blue light coming in from this side. So I get it bathed in blue light over here, bathed in green light over here. I've got white light coming in this way, and I've got off-white light coming in this way. I can hardly notice the off-white anymore, except for that reflection there, just based on having the blue and green coming in there, which is neat. But let's suppose you wanted to have a light source that was actually coming from a location, not from far away. Maybe you want to do a demonstration of an optics experiment with a candle, and you want to place the candle actually there and have it illuminate in all directions from there. You wouldn't want it far away. You would want a local light source, not a distant light source. Well, for that, we're going to use the local light function. Like with everything in Python, I can give this a name, so I'm going to want to modify this a little bit later. And so, for example, here I can create a local light source. Let's create it right at the origin, so right in the middle of all 4 of these spheres. And let's give it the color red, just so we can distinguish it from all the others. So Control 2 to run. And now what you notice, I get a position, right? The red light's position is 0, 0, 0, but it no longer has a direction. Direction is now undefined because it's going out in every direction. It's like, well, what direction is coming from? Well, it depends on where you are, because if I'm at this sphere, it's coming in from the left. If I'm at this sphere, it's coming in from the right. If I'm at this sphere, it's coming in from the bottom. And if I'm at this sphere, it's coming in from the front. So you can't see it, but I have a red light source here, and I can tell it's there because I see red light over here. I see yellow light over here. We've got a little bit of color addition going on here. And then I see a red light here and a red light here. Okay, so my colors are interfering with each other. So I'm going to comment out the 2 distant lights. So we're only going to have the 2 original whites, and we'll have the red now. If I really want to make this clear, I can remove one or both of these original distant light sources. I can say del, what's this going to be? Scene.light. So del is how you delete something from a list. If I just say delete scene.lights of 0, I will get rid of this first item here. So watch, the 22, 44, 88 is going to go away. Let me hold it one away. And notice I don't have light coming in from in front of the screen now. I just have the light coming in from the middle here. And I have some light coming in from the back. So I can really see the red light now, right? I can see that there is some light source in the middle there. So this might be a fun game to play with your students, would be find the light source. But you notice that the light source, this local light, doesn't actually show up. It's emitting light, but I don't actually see where it is. If this were a candle, I haven't created the flame yet. So what you can do with that, you can just create an object that's at the same location there. So what I've done here is made a red sphere that's going to be located right where the local light is. So I'm going to give its position to be the lamp's position and make its color equal to lamp.color. So this will be just a little visual. And now you can see that that's where the light is coming from. It looks a little weird that you have this dark source of light. So maybe it's a black hole giving off Hawking radiation. Let's put the original light back in. There we go. Now I can see the light source there. I need light in order to see light. That's a little bit meta. But what's neat about this, now that I have this thing stored as an object, I can make edits to it, right? Because this lamp, this local light, is an object just like my shapes are. So I can animate the light same way I animate shapes. Let me give you an idea of what this might look like. Here I've got a loop to create an animation. If you've not seen the VPython for Beginners episode about making animations in a loop, I'll have a link to that video in the description below. What we're going to do here, we're just going to loop over 10,000 times. We're going to go at 100 frames per second. And basically, each time we're going to update the lamp's position. We're going to make it go in a circle. So anytime you want something to go in a circle, just parameterize it with a cosine function and a sine function. So each time it's going to go to a different cosine and sine value. You're going to go around in a circle in the XZ plane. Notice Y is fixed at 0. And then I'm going to have my red ball just update its position to be the lamp's position. Let's see what happens here. And so what you see here, first let's take a look at the lighting. So you notice that the lighting is moving around and around. So I can see that on each sphere, the lighting source is moving because the reflection location is moving. Looks like a siren there. But then I have moved the red dot just to keep it moving around with the light source so that you can see where the light source is coming. So the sphere is not creating the light, but the sphere is attached to the light. So anyway, I hope that's useful to you. If nothing else, it's a very fun way to make your animations more visual and engaging. If you come up with an activity of how to use this in, say, an optics demonstration, I would love to see that as I move into another semester of teaching a Physics 2 lab where we need to do some of these optics activities. Thank you so much for watching. I will see you next time. Bye-bye.